Okay, hi everyone. So in this video, I will be attempting yesterday's Codeforces Div3 round, and I will be participating in it virtually through virtual participation. And yeah, let's see how this one goes. So I haven't seen the problems as of now. Okay, I will have to register for it. Should I make it 36, 35? Should be fine as well. Yeah. Okay, great. So 20 more seconds to go. And I hope my Sublime is working fine. Fine. Okay, 5 more seconds to go. Okay, starting with problem A, and it is taking a lot of time to load. Okay, so Polycarp has 26 tasks. Each task is designated by a capital letter of the Latin alphabet. The teacher asked Polycarp to solve tasks in the following way. If Polycarp began to solve some task, then he must solve it to the end without being distracted by another task. After switching to another task, Polycarp cannot return to the previous task. Okay, can only solve one task during the day. Every day he wrote down what task he solved. Now the teacher wants to know what if Polycarp followed his advice. Okay, Polycarp solved the tasks in the order. The teacher will see that on day 3 began to solve the task B. Okay, then on the 5th day he got distracted and began to solve the task C. Okay, on the 8th day he returned to the task B. Okay, cannot have any suspicions. Okay, so began to solve some task, then he must solve it to the end without being distracted by another task. Okay. Find out if the teacher might be suspicious. Okay, so if you are solving a task, you need to complete it, otherwise you seems fine. So all you need to check is that a character is coming in a contiguous way. Like it should not be something like A, B, C, and then A again, right? So and then we can have something like visited. Okay. Okay. So we can basically store the positions of each of the characters that are coming here. So I can have vectors here, right? Yeah. Right, and then we can just check if they are coming in a form of contiguous way or not. Okay, so we can basically get the first value and get the last value. Okay. So if a2 minus a1 plus 1 is not equal to here, then you do so this should be fine. Let's see. Okay. No, no, yes, yes, yes. Okay. Let's submit this. Okay. Okay, so we've got an accepted verdict here on the very first problem. Let's move to problem B. So let's call a positive integer n ordinary if in the decimal notation all its digits are the same. Okay. Find the number of ordinary numbers among the numbers from 1 to n. Okay. Okay, so can I do something like a binary search here that, in fact, a binary search won't be required also here. So I need to check for 1, then 2, then so on up till 9, right? In fact, I can keep it like a string here. Should I keep it like a string? No, no. It is fine as a number only. Okay. I don't need this count actually. Yeah, this should be fine. Let's see. So I'm doing like a very simple brute force here. 1, 2, 3, 4, 5, 18. Okay. I'm just checking all the possibilities. So it is something like 9 into, I would say. Yeah, it is something like 9 into t. In fact, you can call it something like 81 into t. Okay, so we've got another accepted verdict. Let's move to problem C now. Okay, so we will consider the numbers a and b as adjacent if they differ by exactly 1. Okay, considered adjacent if they have a common side. Okay, for a given number n, construct a square matrix n into n such that each integer from 1 to n square occurs in the matrix exactly once. If R1, C1 and R2, C2 are adjacent cells, then the numbers written in them must not be adjacent. Okay, they must not be adjacent. Okay, so the adjacent numbers should differ by more than 1. That is the point here. Mhm. And why doesn't it work for 2? Let's see. So you have 1, 2, 3 and 4. So you can have a 3 here. Okay, yeah, it won't work for 2. You cannot place 1, 2, 3, 4 in any way that such that uh, two adjacent numbers differ by more than 1. Okay, but it works for 3 here. Can I simply extend it for the case of 4? So what are the numbers that I need here? I need 10. Okay, I need 10, 11, 12. I need these numbers. Right. Okay. 10, 11. I can place a 10 here. Right. So I can place it like this, but then okay, can I place all the odd numbers on the odd cells and all the even numbers in the even cells? Will that help me in any way? Okay, let's see. So I need to place all the numbers from 1 to n square. So I can place the numbers like this: 1, 3, 5, 7, so on. And then I need to place 2. So then I can place 2, 4, 6. Okay, but then there can be a collision here, like The 6 can come under 7 as well. That is the problem. Right. 430 people have solved it, and okay, not adjacent matrix. Okay, let me think about this. Okay, so I think I can first place all the odd numbers. Like, uh, yeah, I think I can first place all the odd numbers here in increasing order, and then all the even numbers in decreasing order from that very point. But should I be placing them in decreasing order or increasing order only? I think increasing order will also work. Yeah, this seems fine. So only for the case where n equals to 2 it does not work, otherwise it works. Right. Else what do I do? First of all, I place all the odd numbers and then all the even numbers. Yeah, let's see. 1357. Seems fine. Let's try it out for some other cases as well. Let's do it for 4. Okay, 1357, 911. Yeah, seems to be fine. This seems fine. Let's try to submit this. I don't know why is there such a lot of lag here. Okay. Okay, still in queue. Let's move to problem D till then, because there is no point in wasting time here. Okay, you're given an array A of n integers. Count the number of pairs of indices ij such that I is less than j and aj minus ai equals to j minus I. Okay, great. It is got accepted. So aj minus ai should be equal to j minus I, right? j minus ai equals to j minus I. So I can change this equation a little bit. Aj minus j should be equal to ai minus I. Okay. So is it like just finding the number of pairs where ai minus ai equals, I mean, where they're same? Maybe that is why this problem had a lot of summations compared to problem C. One, three, three, 10. Okay, seems fine. So this was like pretty easy. All you had to do was transform this equation. Okay, great. So moving on to problem E now. I don't know why is it so slow today. Okay. So you're playing the game arranging the sheep. The goal of the game is to make the sheep line up. The level in the game is described by a string of length n, consisting of characters dot and star. In one move, you can move any sheep one square to the left or one square to the right if the corresponding square exists and is empty. Okay. The game ends as soon as the sheep are lined up. That is, there should be no empty cells between any sheep. Okay. Described by the string moves to the position right. Mhm. Sheep at position 2 moves to the right as well. Mhm. Okay. For a given level, determine the minimum number of moves you need to make to complete the level. Okay. This is weird. I don't know. Like, what are they trying to ask here? You need to just club all of them together. Is that what the question wants? I guess so. Okay, so can I decide on the leftmost position of this whole clubbed part? If I can iterate on the leftmost position. Right. Okay. So this is like the string. And if I decide that I want to put all the sheep here, starting from here and till here. So all the sheep from the left have to come here, and from the right they have to come here as well. So let's say I have X sheep and I decide that this is the segment that I want to put them in. Then all of the X sheep should come in this segment, right? So how will I club them in order to have minimum number of steps? So the leftmost sheep should come to the leftmost point. Then the next sheep should come here. Right. So it will be like the absolute difference of getting to that point from where you are to getting to the destination, and absolute difference of that. Okay, another thing to notice here is that there has to be at least one sheep from all of them which never moves. Because if you're moving all of them, then it does not make sense, right? There has to be a sheep that does not move at all. Can I iterate on that sheep? So let's say there are so many sheep here, and this is the one that I chose that this will not move. So what will happen is that all of the sheep that are to the right of it, they have to get clubbed towards the right of it, and all of them that are to the left of it, they have to get clubbed here, right? So I can iterate on all of these sheep. Right. But why is it so that one of them does not move at all? So for example, if you have only two sheep, then it is not necessary to move both of them, right? You can only move one of them and the answer will be the exact same. So there has to be one sheep that never moves. You can keep it as it is, and all of the others, they get arranged according to that. Yeah, this seems fine. So what is the input here? So I will have to keep a count of the number of sheep here. In fact, I can do it in a different way. I can iterate on each point that this is the point till which all of the sheep to the left get clubbed here and all of the sheep to the right get clubbed here. I can do that as well. Okay, so for that I will have to keep a track of the prefix and the suffix. Right. And similarly for the suffix, I will have to do that. Suffix at I equals to someone and count 2 at I equals to. And maybe I can make them as vectors. So it will be easier to debug here. Right, let's see. So for the first one, you have 0, right? Then you have 1. Fine. Then you have 1 again. Then you add 3. Yeah, this is fine. And for the suffix, first you have 0, 0. Then you have 3. Yeah, then you have 3 again. Yeah, suffix also seems fine. Okay. So then all I need to do is I need to iterate on the middle point. Okay, so ll sheep to left equals to count 1 at I. So these are the number of sheeps that are present to the left, including this point. It will do n plus 1, in fact. Or rather, I can leave it like this only. So these are the number of sheep to the left of it. And what will be the sum then? Prefix at I. These are the sum of indices that the sheep are currently present at. But we want the sum to be a little different here. So we will be starting at I minus sheep to left plus 1. So this will be like a sum of AP here. So this will be the sum to the left of it, and then we need the sum to the right of it. Right. Sheep to right equals to count 2 at I plus 1. Okay, so there are certain sheep to the right of it. And that will be the sum of 10, right? Yeah. Here it should be sheep to right, suffix at minus sum to right. Okay, so here I'm calculating the sheep to the left of it, the number of sheep that are to the left of this point, including this point obviously, and then I'm calculating the sum of AP starting from here, going all the way till the number of sheeps. Yeah, this is fine. And then I'm subtracting it. Yeah, that is fine as well. Similarly for here, I'm sheep to right is greater than 0. Okay, so now I need to just write that helper function. So here I need the sum of AP here. Here this is 1. Okay, let's keep it like this. Yeah, let's see. So here I have 2 as the answer here. Okay, I should have had 1 as the answer, right? Okay, let's try to see the very first case here. Okay. So how is the answer right coming as 3 here? Uh, sheep to right. So there are 2 sheep to the right of it. So you have 1. 1 plus 2. Yeah, that should be 3. What is the suffix that I present? So sum to the right is coming out to be 1. Shouldn't this have been I plus 1? Yeah, now it seems fine. Okay, let me try to submit this. I haven't seen the equations completely, but I think it should work. Okay, great. So it has got accepted. So moving on to problem F now. So problem E, I would say, was like a lot of math. Okay, so you have an interactive problem in Div3 as well now. The number of queries is limited to 20. Polycarp is playing a computer game. In this game, an array consisting of zeros and ones is hidden. Polycarp wins if he guesses the position of the kth zero from the left t times. Can make no more than 20 requests of the following type. Find out the sum of elements in position L2 are inclusive. Each guessed zero turns into 1 and the game continues on the changed array. More formally, if the position of the kth zero was x, then after Polycarp guesses this position, the xth element of the array will be replaced from 0 to 1. Okay. This affects something only when t is greater than 1. Yeah, that is right. In the easy version, t equals to 1 and the number of queries is limited to 20. Okay. It's playing a computer game. In this game, an array consisting of zeros and ones is hidden. Polycarp wins if he guesses the position of the kth zero from the left t times. Can make no more than 20 requests of the following type. Find out the sum of elements in position from 0 to L. I mean L to R. Okay, so you can just do something like a binary search here to find the kth zero, each of which contains one integer k. It is guaranteed that at the moment of the request, the array contains at least k zeros. In order to get the next value of k, you must output the answer for the current value of k. Okay. So how does it work actually? In this case, k equals to 2. But how is the input format here? Like they haven't told anything. First, your program must read two integers n and t, right? The t lines follow, each of which contains one integer k. That the array contains at least k zeros, okay? You must output the answer for the current value of k. Okay, so here it is only t equals to 1, so we don't need to care anything about it. Okay, so I think I can do a very simple binary search here, and binary search should take at max 20 operations, considering log of 10 to the power 20, 10 to the power 5 here. Okay, let's see this one. Okay, 6 and 1, and then I can do so 1 till 3, 1, 2, 3, and we have 2 here, 1 and 1, 1 and 2. Okay, seems fine. So was this only that was required here? Let's try to submit it. Okay, were they asking for the zeroth? Okay, I think I've made a mistake here. So they should give wrong answer on test one. Yeah, they're asking about the kth 0 here. 6 and 1. And then they want the second 0, right? So let's do it this way. 1 and 3. And how many? Okay, so the sum is 2 here. 1 and 5. 1, 2, 3, 4, 5. So here the sum is 3. 1 and 4. So the sum is 3 again. Okay. Now it seems to be fine. Okay, great. So now I'll have to see how this hard version of the problem goes. The easy one was like pretty easy because it was simple binary search. Okay, so what if I just divide this whole array into small segments? Like I think that can help me in reducing the number of queries. So if I can just reduce this whole array into segments of 10 elements, let's say this is the first 10 elements, this is the second 10 elements, and so on. And I can query all of them, and that will require approx. What is the size of this whole array? 2 into 10 to the power 5. So this will require 2 into 10 to the power 4 operations initially. So what will happen at this point is that I will have determined that what are the number of zeros in each of these segments, right? And then what do I do? Then let's say it tells me to find the pth 0. So first of all, I'll look for the segment that has so many zeros, like the whole prefix sum. And if I'm able to determine that this is the segment that will be having that pth 0, so what I will do is I will subtract all the number of zeros that are present till the block coming before that, and I will look for the p minus x at 0, let's say, if x is the number of zeros that are coming towards the left of it. And as soon as I determine the position of this, I will subtract 1 from this, and it will be like same then it does not have to be anything else. Yeah, this is fine. This seems fine. So overall the number of queries will be 2 into 10 to the power 4 plus every time I query, and that will be log of 10. So that's like 2 or 3 queries at max. Yeah, this seems fine. This seems fine. Okay. So I will have to divide my whole array into segments at this point. So first I've taken k as the input. Right. Okay, so these are the number of segments here. I plus 1 into 10 and n. Right. So I have the lower limit and the upper limit. Okay, so from this point, I have all of my segments pre-computed. I know the number of zeros in each of these segments. So I can have the size also. Okay. So I know the number of zeros in each of these segments because I know the number of ones in each of these segments and the size of each of these segments. Right. So what else do I need here? Let me see how much time is remaining first of all. 26 minutes. Okay, then I need to do that prefix sum. And I will also have to subtract from the suffix overall. So maybe I need a segment tree here. And I will also have to do lazy propagation in that. Okay, let me just copy my segment tree code for that. Okay, I don't need this one. Right. Okay. So this has to be a type. Okay, now I need to build my segment tree here. Okay. Okay. So now we have our segment tree built here. Now I need to do the query part. Oh my god, this is such a lot of stuff. Okay. Now I need to binary search for this index. Then you have 0 till mid. So if x is greater than equal to k, then you know that there are k many, I mean there are so many zeros present here. Okay. So at this point, you know the segment number that you have to look for your answer in, right? So you have your left and your right. Okay, should I write the binary search again here? Left and mid, okay. Mid minus left plus 1. Okay, this seems fine now. Let's test it out. Okay, 1 to 6. So that is for the pre-computation part. The answer is 1, 2, 3, 4. Then they're asking for 0 to 2. So this shouldn't have been 0 to 2 actually. This should have been, okay. I think I can pass +1 here. One, 2, 3. So till 1 and 3 we have 2. 1 till 5. Okay, seems to be fine this, but yeah. Okay, let me see. Let me check my code first of all because there are a lot of chances of having typos here. So this is fine. This is fine as well. Now this should have been plus here. Okay. So this is the querying part. This is fine. And here I'm finding the segment which will include it. So how do I know that my answer is correct after printing every query? So like you had 4, this is the answer for that. 1, 1, this is the answer for that. Then you have this is the answer for that. Then so how many queries are asked? 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4, 5. I don't know. So I think this is not required here. Answer on test 18. Okay. So you have n and t in segments pre-computed equals to false. Okay, I haven't done this. So it worked till 18 test cases. I think it should work overall then. Okay, wrong answer on test 18 again. So why is it that you're having a wrong answer here? So this is for the segments I'm querying. If x is greater than equal to k, then answer equals to minimum of answer mid. Okay, fine. So this is the left index and this is the right index. Answer plus 1 into 10 minus 1 or n minus 1. And already here are the number of zeros that are already present in the previous segment. Right. 0 till answer minus 1. So the number that you need to find here is k minus already here. And then you update 0 n segments minus 1, 1 answer, n segments minus 1. So I hope the update part is fine here. Tree at index plus equals to value. I think there is some issue with the update part. Like if there is a complete overlap, this should have been start. So I don't think there is time here to make more changes. So let's just submit it again. Okay, so I will have to see what is the issue in this problem. But yeah, that was it for this video, and I will be ending the recording.